Hello everyone, we're here today to talk about Math 100, section 1.8. And first, let's take a look at some expressions we want to simplify. Here, we got 4x plus 8 plus 9. We want to combine this plus 8 and this plus 9. Well, if I wanted to add 8 and then add 9, that would be the same as just adding 17, right? So I can simplify the expression by combining the numbers by adding and subtracting as needed. Similarly here, if we want to simplify this, we can distribute this 4 into the parentheses. 4 times 3 is 12m. 4 and 2 make 8n. So I get 12m minus 8n. Similarly here, we want to distribute. So I've got 6 plus 3 times 4 is 12. 3 times 5, oops, sorry, I forgot the k. Plus 3 times 5 is 15. Now, we're going to use the fact that we can add numbers in any order to rewrite this as 12k plus 6 plus 15. Remember, addition is commutative. We can switch the order because now we can add 6 and 15 to give me 12k plus 21. And then in our fourth example, we have 5 minus, I'm going to put that floating 1 there so we can see it. Remember, whenever you have no number out in front of the parentheses, there's always a hidden 1 there. Then I distribute the 1. Be careful of the negative sign, right? Be careful of that subtraction sign because it's going to be 5. 1 and 2 make 2, but it'll be minus 2y. And then 1 and 8 make 8, but because it's double negative, it'll be plus 8. Now, I'm going to use the same trick to rewrite this, but I need to be careful. I need to respect the signs. I'm going to put the y first. Negative 2y. The 5 is positive, so it'll be plus 5, and the 8 is positive. Make sure you respect the signs on every single value. You need to make sure the signs stay the same. Don't change the signs. Because now I want to combine 5 and 8. Negative 2y, 5 and 8 become 13. So that simplifies to negative 2y plus 13. So I simplified the expressions. And that's what we're going to focus on today, is how to simplify expressions as much as we can. And for that, we've got two definitions we want to start with. Terms. Terms are multiplicative combinations of constants and or variables. Some examples. The number 17 is a term. Or maybe we have negative 3x. That would be a term. Or maybe we have positive 5m squared n. That would also be a single term. Notice they're multiplying, right? Here we have 5 times m times m times n. The squared tells us we need to multiply by m twice, right? They're multiplicative combinations of constants and variables. A coefficient is the constant portion. So in my examples, this has coefficient 17. This has coefficient negative 3, and this has coefficient 5. It's the number out front. So the coefficient is the number out front. Like terms. What are like terms? Are terms with exactly underlined. Make sure it's important. You know it's exactly the same variable portion. And then we'll have some examples of like and some examples of unlike. Examples of two like terms, 2 and negative 7. They have no variables, so they're like. Maybe I have 5x and 17x. They both have x on them. They're like. Maybe I have 4m squared n and negative 3m squared n. The m squared n part is exactly the same. The variable part is exactly the same. Some unlike terms might be 2 and maybe 2x. Notice this has no variable, and this has a variable. They're unlike. And then in the next example, maybe we have 4y and negative 3x. X's and y's are not the same, right? Those are unlike terms. Maybe another example, we've got 3x and 3x squared. Those are unlike. X and x squared are not exactly the same. So make sure you're keeping the exactly part in mind, right? It has to be exactly the same. These are not exactly the same variable portion, right? So we can have like and unlike terms. The reason we like terms, we got a double like there, right? The reason we prefer like terms is because we can combine them. Like terms can be combined. And that's what we're going to look at here. Let's combine some like terms. Here I've got negative 9m plus 5m. I know my answer is going to have an m when I combine the like terms, and I'm going to add the numbers in front. Negative 9 plus 5. Negative 9 plus 5 is negative 4. So I get negative 4m when I combine them. In my second example, 4x plus x. Well, remember, that second x is secretly 1x, right? So my answer is going to be 5x. In my third example, 6r plus 3r plus 2r. Well, 6 plus 3 plus 2 is 11. R. In my fourth example, 16y squared minus 9y squared. If I want to combine those y squared terms, 16 minus 9 gives me 7, and I keep the y squared. In my last example, 32y plus 10y squared. I'm done. I can't combine. Are there any like terms? Nope. These are different. Y and y squared are not like. So my answer would be 32y plus 10y squared. There's nothing to simplify. I can't simplify anything there. So what steps do we take when simplifying an expression? Well, step one, we need to clear parentheses. If the question has parentheses in it, the first step is get rid of them. You have to clear parentheses. Then the second step is combine like terms. Those are the two steps. We get rid of the parentheses, then we combine any like terms we can. And what better way to check it out than to dive right in? 14y plus 2 parentheses 6 plus 3y. Well, I got to distribute to get rid of that parentheses, right? I need to bring that 2 inside. 14y, 2 and 6 make 12, and then 2 and 3 make 6y. Now, I need to identify which terms are like. I have 14y and 6y. I'm going to combine them. They're both positive, right? 6y is positive and 14y is positive, so they'll combine to be 20y, and then plus 12 will still be there. The plus 12 didn't go anywhere, right? I just combined these two terms. Let's take a look at our second example. We have 9k minus 6 minus 3 parentheses 2 minus 5k. I need to distribute the minus 3, right? So I'm going to get 9k minus 6. Negative 3 and positive 2 make a negative 6. Double negative here, right? 3 and 5 make plus 15k. It's plus because double negative, right? Now, let's look at my like terms. I've got 9k here and plus 15k here. When I combine those, 9 and 15 make 24k. Then maybe I use a squiggle to underline my constants. I've got numbers as well. I've got minus 6 and minus 6. Be careful. Minus 6 and minus 6 combine to make minus 12, right? If you take 6 away and then take 6 away again, that's the same as taking 12 away. Be careful of your signs. Make sure you're aware of the plus and minus signs. Let's take a look at our third example. I'm going to put a little 1 here because it's hiding out front. Remember, you can always write the 1 when it's hiding out front. And we're going to distribute. Negative 1 and 2 make negative 2. Negative 1 times negative r. We got a hiding 1 right there as well, don't we? because negative 1 times negative 1 is positive 1r. And then this plus 10r hasn't gone anywhere. I'm just distributing, right? Notice we had some hiding 1s, though. Negative 2 has no like terms, so I'll skip past it. R and R, I can combine r's, right? Positive 1 and positive 10r combine to be positive 11r, right? We can add them together. Maybe we're scared of fractions. Maybe we want to skip it. Maybe we want to see another example before we do fractions. It's okay to do things out of order, right? Let's check out number 5 first. Number 5, I've got parentheses. I need to clear them, right? I've got 5 times 2a minus 6. That's going to become 5 times 2 is 10a. 5 and minus 6 make minus 30. Here I've got a minus 3 out front to distribute. Minus 3 and positive 4 make minus 12a. Then we've got a double negative. This is going to be plus 27. Now I've got a's here and constants here. Those are my like terms I need to combine. Be careful of the signages, though. I've got 10a minus 12a. 10 minus 12 is negative 2a. Be careful. It's a positive 10 and a negative 12. I need to be careful of the signs. Negative 30 and positive 27. Different signs. The difference between 30 and 27 is 3. Now the only question is, do I put a plus or a minus here? Well, which number is bigger? 30 is bigger, so the answer will be negative. It'll be a minus 3. And that's that one. So the only one we have left is the fractions problem. Let's take a look here. I see negative 2/3 x minus 6 minus 1/6 x. I see fractions and non-fractions, so the very first thing I'm going to do is put a 1 over 1 out in front of the x. That's the same as the number 1, right? Put the 6 over 1 and keep everything else the same. I'm converting my non-fractions into fractions. Now I can distribute the negative 2 to both of these. Or sorry, the negative 2/3 to both of these. Negative 2/3 times 1 over 1. Well, 2 times 1 is 2. 3 times 1 is 3. And it stays negative because negative and positive make a negative, right? Here we've got 2 negatives, so be careful. Negative and negative make positive. Positive. 2 and 6 make 12. 3 and 1 make 3. And then we've got minus 1/6 x on the end. Now I'm going to put my answer right here, but I got to be careful. I've got like terms. I've got x and x right here. I have to combine those like terms, and then this one here has no like terms. 12/3 has no like terms, right? So let's work with these. I'm going to do a little bit of scratch work. I have negative 2/3 minus 1/6. Notice I didn't write the x for my scratch work. I'm just trying to figure out what the numbers out front are going to combine to. So I'm going to do negative 2/3 minus 1/6. Notice I'm being careful of the signs. Subtracting fractions requires common denominators. 3 can become 6 by multiplying by 2. If you do it to the bottom, do it to the top. Negative 4 over 6 minus 1 over 6. Well, let's see. They're both negative, right? They're both the same sign. So when I subtract them, I'm going to get negative, let's see, 4 minus 1. Let's see, that'll be negative 5 over 6, right? Be careful of the signs. A negative number minus means you're adding the numbers together, right? They have the same sign, and the 6 doesn't change. So I'm going to get negative 5 over 6 in front of the x. Notice I just did a bit of scratch work up above to figure out the fraction in front. I don't need to do it right in line with the rest of the work. I can do it on the side as scratch, right? Then I got to do 12 over 3. Does this reduce at all? 12 over 3? Yeah, that becomes plain old 4, right? 12 divides evenly by 3 to give me 4. So I get negative 5/6 x plus 4. Notice we had to be a little carefuler with that one. We had fractions in the mix. We had to be cautious, right? Always make sure you're being careful with fractions and following the fraction rules, right? And that brings us to the end of section 1.8. As always, thanks you for joining me, and I will see you next time.